Building our adventure truck includes a lot of formed sheet metal parts. In my opinion, formed sheet metal is one of the best, most economical, and most lightweight methods of making parts for an off-road rig. So I'm going to take you along in building a bracket, which is an afterthought. We got an air fryer for Christmas, so I want to put it in the camper. So I'm going to make a combined bracket to hold it. Come along for the ride. In my opinion, formed sheet metal is one of the best, most economical, and most lightweight methods of making parts for an off-road rig. The material is very inexpensive. I usually use anywhere from 40 to 60 thousandths aluminum. I use simple tools, and I begin with a fairly simple part. Beginning with an idea of what you want to have is where you need to start. So what does a finished product look like?
We got a new air fryer, and it needs a home about right here.
There's a lot of guys who just say, I'll just start working on something and I'll eventually end up with something. Well, if you try that with sheet metal, you're going to end up in nowhere. So you really need to start with a very firm idea of what the end product looks like. And then from that end product, then you have to backward plan through it to determine how it's going to be made and how it's actually going to result in the parts that you want. Once you've got the final product in mind, you have to be able to unfold it back into a flat sheet, because if you can't unfold it into a flat sheet, you can't make it from a flat sheet. So you have to start off with what's called a flat pattern. Once you've got your final concept in mind, sit down with a sheet of paper, and that sheet of paper is your sheet of aluminum, and you have to decide where you're going to cut, where you're going to bend, where you're going to bend up, where you're going to bend down, and how are you going to do it, because there are tooling limitations in addition to process limitations.
I plan it out how I want it shaped and sized, and then I do a flat pattern drawing. So the dashed lines are folding lines. So this is the bottom. And so this will get folded up along this line and up along this line and up along this line and up along this line. So what we'll end up having is an L-shaped box with a bracket on the side. So that'll be folded up like that, and the back will be folded up like that. And then there will be two flanges on this side. So that's kind of how it works. Part of this whole process is important to understand where these bends need to be made, and what order in which they need to be made, because this tab right here and this tab right here need to be bent upward before this line is bent, because this is a front. This is 1.25 inch tall flap on the front that keeps the air fryer from sliding out. So this gets bent, these whole lines get bent, and that means that this tab and this tab are going to collide with each other. So then I fold this in just a little bit, and then I make this fold right here so that these tabs fold inside of the sides. And then the same thing happens in the back, is this fold here, these bends here need to come inside of this and this, so these bends get pushed a little bit at the corner, just a little bit of area right here. They just get bent in by hand. So when I form this up, that they end up inside of this flange. I'll try to show that to you when we get to that point, but that's how we plan our forming.
The equipment that I have and use is probably fairly common, and so that it drives how we're going to build this part. But again, so if I design my part, I've come back with a flat pattern of how it's going to be made. The very first thing I'm going to do with that flat pattern is I'm going to start off with a sheet of aluminum. And I typically use anywhere from 40 thousandths to 60 thousandths aluminum. For most of the stuff that I make, it's completely adequate for most of the strength I need. And the biggest part of the tooling that you need really is this marking equipment. Because the first thing you're going to have to do is transfer your pattern from your plan onto the part itself. And so you're going to use a number of different squares, so either 45-degree angles or 90-degree angles. If you want to have variable angles, you're going to need a protractor square. The biggest thing of all that I mark it with is I got an ice pick right here. This ice pick is almost as old as I am, And this, just scribing the line directly onto the aluminum is probably the best way to do it. It does leave some residual marks, but you can polish them out if you really don't want them. But it's, for as far as crisp and clear, this is the tool to have. You also may want a compass if you're going to put any round holes in it. But the biggest part of the project is measuring and marking out the flat pattern. Because if you can't measure and mark it out, you won't make it.
So this is a piece of sheet metal that I have, and you can see the drawing here in the corner, and I flip it around a little bit to try to figure out what's the easiest way to cut. A lot of times I like to try to keep a finished edge of the product along the finished edge of the material, which, as you can see, that's how that corner got cut out. But now I'm going to try to make best use of this. So, you know, flipping this different directions and observing, this is a 21¼ inch long edge here, and this whole thing is what, about 19 inches wide. So it actually probably works best for this corner right here to go right there. So you can see this line here goes over here. This corner is this. Here's my diagonal line out here.
Now, from the flat pattern, there is a few simple things that you're going to have to do. You're going to have to look at, okay, from this flat pattern, I'm going to have holes in it, I'm going to have cuts in it. Those things get made first. So you're not waiting till the end to drill and cut. If it's a small hole, you can wait till the end, but for the most part, you're going to want to cut notches out of corners. You're going to want to cut lines and seams, and almost exclusively, I use my table saw to do this. If you're working with aluminum, essentially the aluminum sheet can be worked with any of your woodworking tools, and cutting with a standard blade on a table saw, I don't even bother to change the blade from what I'm cutting with, and it might be a fine tooth blade, it might be a coarse tooth blade, it just really doesn't matter that much. Cutting aluminum on a table saw is exceedingly easy. I also use a bandsaw, and the bandsaw I usually use to cut little corners out of things, and so the bandsaw is very useful to me. This is one of the tools that you're going to need right here. This is a deburring hook. This is a pretty standard machining tool, and it just has a razor knife edge on there, and you can just drag it along the edge and remove the chipping that the blade produces. And once you've got a deburred blank, now is where you want to bend the blank into the part you want to have. Now, this is where you really need, before you make the very first bend, you need to work yourself through the process of how this is going to be made, because you will paint yourself into a corner. And literally, it's just like that. If you were to just start painting anywhere, you're going to find yourself standing in a corner with three painted walls and a floor, and you can't get out of it. And that's exactly where you'll be with sheet metal if you don't plan each bend.
What we're going to do first is we're going to form along these two long edges right here, which is this line right there and this line right here, to form these sides up. And then what we're going to have to do is then fold these two little tabs in here and fold a little bit of this corner in here, so we can then make these two longitudinal bends.
There's two bending tools that I use. Of the categories of bending tools, there's a press brake and there is a bending brake, and this is referred to as a bending brake or a bending leaf brake. And then specifically, this brake is somewhat unique in that it has what's called fingers at the top of it. So these are 4-inch, 3-inch, and 2-inch fingers in here, and these are all unlocked with this simple tool, and they can be slid, they can be removed. And this is necessary because part of what you're going to be building is you only want to bend over a certain length of part. So you're going to want to be able to adjust the length of the bend. This is a 4-foot bending brake, and it'll bend up to 16 gauge mild steel, which means it'll bend pretty much any kind of aluminum that I want to put in it. I bought this tool used for about $400, and it's new. It has probably $1,000 new these days. But you can buy much smaller tools, and you can buy cheaper tools. This is not a very sophisticated tool, nor a very expensive one, but it does what I need it to do. Speaking, what you're going to do is you're going to start with your material all the way inside the brake. These handles raise up the throat of this brake. You slide your sheet metal in here, and you're going to make you're going to slide it all the way in. You're going to make your first break, first bend, because you're going to continue to pull the part out as you bend it. And if you don't understand that, you're going to find yourself painted into the corner of a room, because you have to understand how this brake works, whether you're going to bend it up or you're going to bend it down. If you're going to bend it down, you've got to flip it out and put it upside down. So you have to have all the consideration of how you're going to form this part in order to use this tool.
Okay, so here we go. The first one, if you can see this here, is the scribe line is matched up right with the notch, in the bending bar and the bending leaf if it's also set back about the thickness of the material from the finger brake. So that should create the room necessary to complete this bend. Lock it down on both sides, and now we're just going to lift up the bending brake about 90 degrees, and I don't get too concerned with how accurate my 90-degree bends are. Going over it obviously is undesirable, but it's usually not too hard to eyeball. Now we're going to do the other side. Okay, so there's the bottom, there's the back, here's the side, and these two pieces here we're just going to bolt onto it. We want these two center leaves here to bend inside of this. We're going to bend this in just a little bit with our thumb and this out just a little bit. It's actually beneficial not to bend it any more than you absolutely have to. Just get started. So in order to bend this, now we're going to have to select our fingers here. So we're going to find the best fit that's on here, which is right there. Those 4 fingers in the middle are 11 inches. So in order to make those accessible, we're taking out that finger. So as you can see, it turns out as it hits this right here, so I'm going to have to bend a little bit and do the rest of it by hand. But that got most of the way there. And this is going to be even worse. A couple of the other tools that I have here, these are hand seamers. These happen to be the vice grip version of them. In a lot of cases, there is a small tab or a small corner or something like that that you can't actually bend on the brake. So these tools are a miniature version of a brake that you can use. This is a 4-inch long, and the one, this is a 3-inch long one. I can bend about a 5-inch long thing. You can bend about an inch longer than these things are pretty easily. But if you have something you can't bend in the brake because of process constraints, you can use these hand seamers in order to do also some of those bends. So use this rawhide mallet, because one of the things that you may want to do is you may want to change the angle of the bend. If you overbent it in the brake, or if you underbent it in the brake, you don't want to hit it with a steel hammer. A steel hammer will leave marks. This rubber mallet, you can bend the material without leaving a mark in the aluminum. So this is a pretty essential adjustment tool. This is where I wanted it. So that's the part. Need a little bit more handwork here. One of the tools to sharpen this bend is actually to use a piece of 2x4 inside there. Okay, let's go test it out. Okay, so here we are doing a little test fit. This one here was supposed to come up just below that rear air vent. It looks fine. It'll be holding it pretty tight. It's right flush with the front and almost flush in the back. Flush on the sides. I got maybe a 1/4 of an inch of space there, so there's a little bit of wiggle room, so I don't have to scrape it up getting it in there. But that should do just fine. Got to deburr it. It's got lots of sharp edges on it. We'll get it some deburred and some screw holes put in it, some rivets put in to hold it square. Okay, here we have my deburring tools. This is a shaving hook. This one here is made for sheet, so you can see it's got a tungsten carbide insert that will deburr both sides of the panel at the same time. Sometimes useful, sometimes not. And then of course just a hole deburring tool. Normally I just prefer to use a shaving hook because it's just more universal, and so that's what it does. Cleans that off pretty well. So that's a 9-inch long distance. So what we'll do is we'll start at 1/2 inch from the top and go at 4.5 and 8.5. I don't have a really good marking pen. Now, because I want my rivet to come in about 3/8 of an inch from the edge, or actually probably more like 1/4 of an inch, and using the edge as a reference, I just scribe. Using 1/8 inch rivet. It's important you deburr these holes. Okay, so the rivets I'm using are 1/8 of an inch by, this is about a 150 thousandths or so clamp range rivet. They use very little on the inside, which is what we want. We don't want to scratch up our air fryer. And we have just a little bit on the inside, but nice and clean. I'm going to do 2 in this corner and 2 in each of these corners here too. These rivets are probably the most common material type. It's an aluminum rivet body with a steel mandrel. It's kind of important to note what the mandrel material is, because the end of the mandrel remains in the rivet. So with a steel mandrel, it'll rust if it's put into an environment where it gets wet. Stain the aluminum. It is not a thing of beauty, highly functional. The one thing I'm going to have to do is I need to put some kind of a latch in the bottom of here to keep the bucket of the air fryer from falling out. Okay, so right here is the answer to keeping that in on the road. This twists up, and not only does it keep the air fryer from the basket from coming out, but keeps the whole air fryer from coming out too. It's got a nylock nut to keep the twisting from loosening it, and if you see the tiny little gap there, it's got a fiber washer in there which allows it friction without scraping aluminum to aluminum. We got it up for a little test fit, which is 40 thousandths aluminum, so it's pretty thin. And what we discovered is we got some twisting going on here. This is what it's doing. This end is sagging down, so we're going to put a reinforcement bracket on here to keep this whole front stiffer and see what that does. Since it's also in coordination with the retaining latch, we're going to put the retaining latch right through it, which it'll actually act as another mounting point, but for the most part this is going to be riveted for its strength. That's a lot stiffer. You can see that it flexes, pulling it out right there, which is nice.
I've chosen to use aluminum as a major contributor in a lot of the bracketry, the things in my camper here. You can see here not only is the air fryer bracket that I just made out of aluminum, but the entire housing for the microwave here, as you can see, is a space laminated piece of aluminum. There's a lot of other fixtures in the camper, and there are some pretty significant reasons why. So let me take you to a detailed spreadsheet of just this bracket here, and I can show you how that kind of carries through with a lot of other things that you might want to do in your camper. I've prepared this analysis here for the air fryer bracket, but this pretty much carries through with all the other forms of sheet metal that I've made. So let's just go through it here. The blank that I used was 21.25 inches square, which makes it 31.5 square inches, or 3.1 square feet of material. And from that, the flat pattern, once I've cut it out of the blank, ended up about 2.3 square feet. So it was about 74% material yield, which means I threw away about 1/4 of the sheet metal. Actually, I didn't throw it away. I had some smaller blanks for smaller projects. So my material choices, as I saw it to make this bracket, were either making out of 40,000 5052 aluminum or 6mm Baltic birch. And so this is kind of how things shake out. This is the material density. So you can see here that the Baltic birch is heavier than the sheet metal is, and that relays from a part which would end up being 1.3 pounds if I made it out of aluminum. It's going to be over 2 pounds if I made it out of Baltic birch, because you can't fold Baltic birch. So you gotta, once you cut the pieces to make the same product, you're going to have to connect them together with some other material. So that's going to add complexity. It's going to add part count. So you can see, but it's 1.3 pounds versus 2 pounds. So the cost of the materials in relative terms are, this aluminum is almost $1.50 a square foot, and the Baltic birch material is about $2.32 a square foot, and neither one of these include shipping if you were going to have to buy these and have them shipped to you. So the cost for the material blank at $1.47 per square foot would be $4.56, and the cost for each of the parts cut out of my Baltic birch would be about $7.20. So it's about a third more expensive to make it out of Baltic birch. The key here is that once I make it out of sheet metal, the part is nearly complete when I get done forming it. Parts made out of Baltic birch gives me a bunch of pieces that I now have to make brackets and fasten those together, and that's going to take quite a bit more planning and more material and more time and more weight. So the advantages, as I see it, the aluminum is weighs less, costs less, is a single part. Additionally, because this holds a greasy air fryer, aluminum is very easily cleaned. The grease is not going to soak into it, but it will definitely soak into Baltic birch. And one of the advantages of Baltic birch is that it's much stiffer material, so the stiffness or the flexibility is going to be much less in a Baltic birch part, which is part of one of my disadvantages for my aluminum. And I did end up having a stiffness issue when I built this, and that was more of the stiffness of the microwave cabinet than it was of the bracket itself. But one other part that you have to think about this is, if you're going to cut a whole bunch of pieces, you have to assemble a whole bunch of pieces with a whole bunch more pieces and a bunch more pieces of fastener, which is going to add significantly to your cost of labor. So not only is the material heavier and cost more, it's going to cost a lot more, and it's going to be much heavier by the time you get done as well. Plus you're going to have to put some kind of clear finish on it in order to keep it from soaking up grease. And so this analysis generally carries through with most of the rest of the equipment that I have inside the camper, because that's why most of it is formed aluminum. So that's the bottom line. I really think that sheet metal is a great way to go inside of a DIY camper, and I encourage you to invest in the tools and the time to learn about it. It's no harder than, cutting it out of wood, and you probably spend the same amount of time and money investing in tools to cut wood as you would to cut sheet metal. So if this is helpful to you, please share it with your friends. If you think that there's other questions you'd like me to answer, please ask in the comments. I'll get right back to you. All right. See you next time.